Okay, so we're going to take a look at some examples of being able to work with sampling distributions. So we have this example one. And example one says that the average number of days that a Ford Escort will run without breaking down is 165. The standard deviation is 15 days. These are population data. The population is normally distributed. Suppose we took 64 Ford Escorts and they were randomly observed for breakdown. All right. Before we even start the problem, let's recall our formulas. So we have our first formula, mu sub x bar is equal to mu. We have sigma x bar is equal to sigma over square root of n. And then the other formula that we have is z equals x minus mu sub x bar divided by sigma x bar. And we're just going to utilize those formulas. It might be helpful for us to be able to get a basis of the variables, right? So in this example, mu, the average number of days, so average number of days before breakdown is 165. So in this case, mu is 165. The standard deviation is 15 days. And then the number of samples, n, is 64. All right, so that's a baseline of things that we have to have before we can even attempt either A, B, or C. So we're going to hold on to that. Now for letter A, it asks us find the mean and to find the standard deviation. Okay, so the mean, mu sub x bar, which is equal to mu, is 165. All right, so it's just that easy. So all you have to do, just go through, identify the mean. It's the same thing as the mean of the sampling distribution. Now sigma sub x bar, which is equal to sigma over the square root of n, is going to be equal to 15 over the square root of 64. And if we punch that into our calculators, that's going to be 15/8, which I think is 1.875. Now I'm going to verify that using my calculator, which apparently I just dropped on the keyboard. So we have 15 over 8, and I got 1.875. All right, so that's for letter A. That's the mean and the standard deviation. Now for letter B, what is the probability in the sample of 64 Ford Escorts that the mean number of days before breakdown is between 164.5 and 164.8? All right, so what might be helpful is if we draw this, just so that way we can get an idea of what's going on. So now remember, we're going to use a normal distribution. Okay, in the middle of this normal distribution is 165 because the average number of days before breakdown was 165. Now remember we had, I think it was 164.5, 164.8. And the area that we're looking for, or the probability that we're looking for, is right in here. Now you may remember from previous lessons that to be able to use the z-score correctly for a between problem, we find the area of the upper, we find the area of the lower, and then we subtract them. Right? So you might remember we had z1 and z2. Now I'm just going to write the formula for z. Z is equal to x minus mu sub x bar divided by sigma x bar. I'm going to do a z1 and a z2. Right, so for z1, z sub 1, I'm going to pick the bigger one. 164.8 minus 165, so that's x minus mu sub x divided by sigma sub x. Now remember we just got sigma sub x, and sigma sub x was 1.875. I'm not using the 15. Okay, I'm going to punch that into my calculator. And I end up with negative 1.11. Okay. Now, we're going to use our z table. Okay, so remember, you go into the z table. I'm going to go to negative 0.1, and I'm going to go over to 0.1, and from the z table, I get 4562. Now we have to find the second z, z sub 2. Okay. Z sub 2 is going to be equal to 164.5 minus 165. We're going to divide that by 1.875. Again, I'm going to punch that into my calculator. And I get negative 0.27. I'm going to convert that using our z table. And if I do that, negative 0.27 should be 3936. Last thing we're going to do is we're going to subtract those two. Okay, so you remember, to get the between areas, you just take the two areas. So our area, our final area, is going to be equal to 0.4562 minus 0.3936. I'm going to punch that in my calculator. I think it's 0626, but 0.0626. Alright, and that's our probability. Alright. Now remember, this represents the probability of the 64 Ford Escorts. Okay, so this is the probability that the mean of those 64 Ford Escorts is going to be between, for the life expectancy, is 164.8 to 164.5. Okay, it has nothing to do with the population. So our last one that we're looking at is we're trying to figure out, in the sample of 64 Ford Escorts, what is the probability that the mean number of days before breakdown is less than 160? All right, so that should be pretty easy because it's a less than problem. Remember, with less than problems, we just find the z-score and then we convert it. All right, so this one shouldn't be as bad. So for letter C, so here's our distribution. Now remember, in the distribution, 165 is still the mean. The value we were looking at was 160. So we'll go all the way over here to 160. And the area that we're looking at is anything less than 160. So it's going to be a small area. Right, so something like that. All right. So, and again, we use the distribution just to make sure it's a check. All right. So if we got something like 80% or 90%, it wouldn't make much sense. So finally, we're going to use our formula. Now remember, z equals x minus mu sub x bar divided by sigma sub x bar. So this is the formula we're using. Okay, I'll just copy it down here. So z is going to be equal to, in this case, 160 minus 165 divided by 1.875. Okay, so I'm going to punch that in the calculator. I got negative 2.67 for z. And then what we're going to do is we're going to go into the table, just like we've done before. So the z table, we're going to get a very small value, so negative 2.67. I got 0.0038. So less than a 1% probability that the average number of days before breakdown of the 64 Ford Escorts is going to be less than 160. Okay, so what I'll do is I'll just type out really quickly what the solutions actually mean, so that way you can interpret those. So for B, this means that the probability that the mean of the mean life expectancy, or the mean number of days before breakdown, of the 64 Ford Escorts is between 164.5 and 164.8 days is approximately 0.0626, excuse me, or 6.26%. And then for C, if I were to interpret what that means, C just says that the probability that the mean number of days before breakdown of the 64 Ford Escorts is less than 160 days is 0.0038, which is equal to 0.38%. So not very likely. Okay, so we just want to make a point that this is highly unlikely. All right. So a suggestion would be maybe to go through and work the next problem on your own, just to make sure that you're okay being able to do these types of problems, and then watch the next video just to make sure that you can do the solutions to those.